Welcome back, welcome back, welcome back, welcome back. Ladies and gentlemen, we are in for a treat. Question number 25 on the 2000 Cayley. That's the last question on the 2000 Cayley paper. Let's hope it's a good one, and we'll dive right in and take a look at it. Hopefully you've already had a chance to take a look at it. You've tried these questions on your own because you get so much more out of trying a question and seeing where your shortcomings are and where your strengths are, especially if you're really serious about writing these contests. So hopefully you've had a chance to take a look at it. Now I'm going to take a look at it, and we'll see if we can come up with the same answer together. All right. So for the system of equations, and that means so we got x's and y's here. System of equation means that if a pair x and y solve this equation, you have to also solve this equation. That's what it means to solve a system of equations. So we don't look at these guys separately. We look at them together. Okay. So we have x squared plus x squared y squared plus x squared y to the fourth equals 525. And we have x plus xy plus, so x squared is 525, and x plus xy plus xy squared equals 35. So 525, 35, those are the actual values that these things equal. The sum of the real y values that satisfy this equation are, or the sum is, sums are singular, not plural. So we have two equations here. 525 and 35 are what they equal, and those are both multiples of 5. Is one a multiple of the other? I don't know my 35 times tables. I'll be honest about that. Yes, it turns out that 525 is 15 minus 35. So we can certainly write the number as a product of the other number. I wonder if we can write this expression as a product of the other expression. Things to think about, numbers that are catching my eye. I don't know if it's going to go anywhere. So we have x squared plus x squared y squared plus x squared y to the fourth is 525. And we have x plus xy plus xy squared is 35. All right, that's the information we have so far. And like I said, I noticed that 525 is 35 times 15. So I wonder, is there a way to write this top polynomial, so the top left-hand side, as an expression in terms of the bottom left-hand side? Top left-hand side, bottom left-hand side, is there a way to express one as the other? So I noticed that up here I have a factor of x squared, so I could write x squared 1 plus y squared plus y to the fourth. And the bottom left-hand side, I could take out the factor of x, and I get 1 plus y squared. Now these look very similar. They really do. I mean, they're basically, on the surface of it, the top one is the square of the bottom one. But you can't square 1 plus y squared and get this value out. Unfortunately, it doesn't work that way. But we could write the top one as, so let's see if we can do this deduction. 525 is x squared 1 plus y squared plus y to the fourth. Okay, so we can take out the x, and we're left with x1 plus y squared plus y to the fourth. So can I get out of this 1 plus y squared plus y to the fourth, can I get a factor of 1 plus y squared? Okay. Now I could straight out attempt it, or I could check, do certain y values, give a factor here. But the problem is, we're asked for real y values. So just testing numbers isn't going to help. I could try and find zeros of this equation and see if that might lead me to think that one is a factor of the other. But if we're dealing with real values, the best thing to do is just say, hey, let's see if we can write that as something. So 1 plus y squared plus y to the fourth equals, and we want a factor of 1 plus y squared. Well, we're going to multiply it by, hopefully, some other polynomial in y. If it turns out it doesn't work, we'll find out pretty quickly. But I want to write this a different way. So we hope we can do 1 plus y squared times some polynomial in terms of y and get out a 1 plus y squared plus y to the fourth. Now, this might end up being a fool's errand, in which case I'll have to go back and take a look at this and see if there's another way to do it. But because we have 525 and 35 as a factor, and we can already pop this x out, I really think we could. Plus, there's a very nice pattern here. So I really think that we can express the one polynomial as a factor of the other. If it's wrong, I'll go back and I'll try something else. So if I want to get this y to the fourth out, I will definitely need another y squared to go with this y squared. So right now we have 1 times y squared, so the y squared, plus y cubed plus y to the fourth. Okay, so we have the y to the fourth already covered, but we have a y cubed in our intermediate expression, but we don't have a y cubed out here, so we need to get a negative y cubed. How can we get a negative y cubed? Well, we take this y squared, and we multiply it by negative y. So that'll cancel out. But it also brings with it a y times a negative y, so that's negative y squared, and 1 times negative y, which is negative y. So, the y cubes cancel out exactly as we want. But so do the y squareds. Okay. So we need to get another a term of y squared in here, because both of our previous y squareds cancel each other out. Well, if we multiply y squared by 1, we'll get plus y squared plus y, and these guys are going to cancel out, plus 1. So it turns out that everything worked out, and we get y to the fourth plus y squared plus 1. So we can indeed write it as a factor. 525 is therefore x times 1 plus y squared. And that we know is 35 times this guy here, x 1 minus y, not minus y squared, plus y squared. So look at that. We used our 35 and the fact that 35 is a factor of 525. Now we could have done this even if 35 wasn't a factor, because we're dealing with real values. We're asked about real values of y. So we could have done this even if it was equal to 22 or something. But we're sort of spurred on by the fact that 525 is a multiple of 35. So this means if we rearrange it, this other expression, this other polynomial in x and y, has got to be 15. So x is 1 minus y plus y squared must be 525 over 35, which is 15. Okay, so I could expand that out and say x minus xy plus xy squared is equal to 15, and this looks very similar to our original equation, or one of our original equations, which was x plus xy plus xy squared is equal to 35. So we have a difference of 20 here. So I can take one equation and subtract it off the other. We'll label these guys. 2 subtract 1 is going to be, these guys are going to cancel each other out. Actually, it might be easier if I just, because of how I have it visually set up, let's do 1 subtract 2. 15 minus 35, we're going to get negative 20. These guys are going to cancel out, these guys are going to cancel out, and we'll be left with negative 2xy. So from there we can see xy is equal to 10. So we have a little bit of information. That's pretty awesome. In fact, we could rearrange this and get x in terms of y, substitute it back into either one of these formulas, I don't care which, and we could get a formula, a quadratic formula, just in terms of y. And we know how to solve a quadratic formula. So let's rearrange and say x is equal to 10 over y. Because we're looking for y values, so we want to put everything in terms of y. We want the real values that y can be. Okay, well then equation 1 becomes 10 over y minus x times y we already know is 10, so we can just substitute that in. Plus xy squared is x times y, that's just going to be 10y is equal to 15. So let's multiply through by y. We get 10 minus 10y plus 10y squared is equal to 15y. And if we rearrange that, we get, I can divide through by 10, so I'm going to get 1 minus y plus y squared is equal to 1.5y, which is really, I should keep it as a fraction. Decimals are not particularly helpful, especially in the middle of a question. It's okay at the end if you want to round everything, but keep everything as exact as possible until the end. So 15 over 10, that's the same as 3 over 2. So I can rearrange and say y squared minus 5 over 2y plus 1 equals 0. Now, we're asked for the real the real values of y, the possible real values that y could take on. Well, they're just going to be the y's that satisfy this equation, right? So, there's two ways we can do it. Because we have a 1 here as the coefficient of our y squared, it actually turns out that the roots are going to add up to negative b, so that's going to be 5 over 2. And that's something that you could pick up if you need to. But, I mean, we could just use the quadratic formula, let's be honest. So y is going to be equal to negative b plus or minus square root of b squared, so that's going to be 25 over 4, minus 4ac. Well, both a and c are 1, so that simplifies things, all over 2a. So that's 5 over 4 plus or minus 25 over 4 minus 5. So this is going to be square root of 25 over 4 minus 16 over 4 all over 2. 5 over 4 plus or minus. And you see, we don't even need to do this because when we add up these two different possible y values, this term over here is going to cancel it out because we have a plus and a minus. But we will continue. 25 minus 16 is 9, so square root of 9 over 4. 5 over 4 plus or minus 3 over 2 over 2. That's 5 over 4 plus or minus 3 over 4. So this is either going to be 8 over 4, which is equal to 2, or 2 over 4 is equal to 1/2. And the sum of the two y values, 2 plus 1/2, it's as I predicted a little while ago, it's going to be 5/2. So let's see, can we find 5/2 somewhere in 22? Oh, there it is at the very end, E. So not only do we know the sum of them, which, as I'm saying, we could have just jumped over here and said it's because we have the coefficient of 1, it's going to be the negative b values, the sum of the two roots. The product of the two roots is going to be 1, and we can verify that 2 times 1/2. But you know, doing it with the quadratic formula, if we were asked to do something else, if it were a multi-step question or something, now we have the roots. It's 2 and 1/2. But we're only asked for their sum, so it's 5/2. So I think that was a good question overall, and I think actually good Cayley paper overall. Yeah, not a whole lot to really complain about. I think there were some good questions. There's definitely some overlap. If you look at the Pascal-Cayley format, there's always 1 or 2 questions of overlap. Question number 17 on the Pascal becomes question number 12 on the Cayley, becomes question number 6 on the format, that sort of stuff. Other than this typo, and I think I made a comment in the last video, I think question 24 needs a little bit more explanation about the diagram. Other than that, I'd say a fairly good paper overall, and yeah. So that's this paper. Join me for another Cayley. I'll be starting up another one soon, and we'll be going to the 2001. Or, feel free to look at any of my other math videos. And I'll see you guys, whatever that video is, I'll see you then. So thank you guys so much for watching, and see you next time.